Bismillahirrahmanirrahim. So today we will start on chapter 5 of the Hill and Davis text, Experimental Economics, and this is on auctions and bargaining. The first part of the chapter covers bargaining, and that's what we will do today. The next part is auctions, which we will do in the next lesson. So basically we start with what is called unstructured bilateral bargaining. Two people haggling over the price of one good. So anybody can say anything and negotiation can get anyway. And this is sort of your basic primitive market where there are no prices, no rules. So what will happen? Well, there is no prediction. The solution is indeterminate. You can think of it as one person wants to get the largest price, the other wants to pay the lowest cost. There is usually some range of agreement which is possible. That is, there is a set of prices at which both will agree, but both have incentive. This is a zero-sum game. Both are opposed to each other in terms of incentives, and so they both have incentive to reveal, to not reveal the correct information. So the person says, you want to buy at this is even less than what I paid for this. Now the other person, but somehow the other person says, this is all I have in my pocket, so this is all I can offer. So these are the kind of... So there is no analysis that is really possible, but we can try to put some more structure and see if there is some results that we can do. So this simple analysis of bargaining provides the basis for more complex situations. So one very simple bargaining game is called dividing a dollar. We put a dollar between two people and you say, okay, you divide it. If both agree, then you get what you want to your agreement. If you do not agree, then the dollar is taken back by the experimenter. So what will happen? This is something, and suppose I put $100 on table. I call any two people and say, okay, you bargain over this, and whatever you agree to, will be your decision. So, and if you don't agree to a split, then I will take it back, and you go. So what will happen? Well, it is obvious what will happen. This happens in 10 out of 10 cases, that people agree to split evenly. And just think what will happen if in this bargaining somebody says, okay, I will take 60 and you take 40. So this cannot happen because there is no reason for that. The other guy will say, why shouldn't I take 60 and why don't you take 40? Because it's completely symmetric. So there is no, so there are 2 points. 50-50 is a focal point. This is a very important concept for later use. It is a focal point in the sense that it is automatically evident that this is a right point. If there is a complex game, you can't see what would be fair, then there are no focal points. And then it is obviously and immediately and transparently fair to both parties. It is also efficient in the sense that the sum of what the parties get is the maximum available, like Pareto efficiency. You cannot give more to both people. So a more general form of this is called the bargaining set, where you have a collection of possible outcomes. It's graphically described as a set. So you can choose any point in this set. So if you think of it as in two-dimensional space, the first coordinate gives what the first player gets, and the second coordinator gives what the second player gets, and you have this set, so you can choose any point. So this is like your bargaining. So the bargaining set in the dollar divide is just a straight line where x plus y equals 1, where x is the first player's outcome and y is the second player's outcome. So now Nash came up with a solution for this under certain theoretical conditions. He said that, okay, let B1 be what the first player gets, B2 be what the second player gets, and suppose that there is what happens in the case of disagreement. So now in the case of disagreement, what you're saying is that both people get 0, 0, but this may not be true in general. So D1 is the disagreement outcome for the first player, and D2 is the disagreement output for the second player. So he said that suppose that the solution, the bargaining solution, satisfies certain axioms, which we will discuss later, then it must be that it maximizes this product of utility functions. So this is an axiomatic approach. This is called the Nash bargaining solution. So these are the axioms that Nash invoked, that the solution should be efficient, that is, it should not be possible to give more to both, and it should be symmetric, that is, if the players have symmetric situations, then the outcome should be symmetric. So just these two axioms are enough to yield the Nash bargaining solution. If you have non-symmetric games, so disagreement points are different and the total amount, the rules of negotiation, the set itself is not symmetric, then you need two more axioms. One is called independence of irrelevant alternatives. It means that you take the bargaining set and you find the Nash solution. If you chop out parts of the set which are not does not include the solution itself, then since this solution would have occurred anyway, so the parts that did not come into the solution should not make any difference. So that's irrelevant alternatives. And there's also invariance under linear transformations. If you make linear transformations to the utility function, the solution should not change. So under these four axioms, you get to the Nash solution. Now, this approach itself is deeply flawed, in the sense that this is you see, I've mentioned many times that there is the Greek approach to world and there's the scientific approach invented by Ibn al-Haytham. The Greek approach says that you close your eyes and you think about what should happen, and that is your science. And the scientific approach invented by Ibn al-Haytham says that let's look at the world and see what is happening and then try to understand what is happening. So these two are very different approaches. So the Nash approach is the Greek approach, that you close your eyes and think about what would happen in bargaining, and according to certain axioms you come up with a solution. Now a lot of the literature is about, and even this literature is about, why Nash bargaining does not work, which of the axioms fails. Now this doesn't really make, this is a sort of an irrelevant approach. We should look at what really happens in bargaining, try to understand what's going on. That is not being done. But anyway, okay, so here is an application. Suppose that I put 100 rupees and I ask people to divide, let x and y be the payoff. So to the two parties, so x plus y equals 100. This is called Pareto efficiency. It means that bargaining should not be that I get 20 rupees and you get 20 rupees and we return 60 rupees to the experimenter. That would be inefficient. And the disagreement payoff is 0, 0. That's symmetric. So according to the Nash solution, then there is only one solution, which is the one which maximizes the product of x and y, if you think of xy as the sides of the rectangle, then you know that the square is the largest area. So the one with equal sides. So if you have different disagreement payoffs, then you can have a different solution. So basically that if the negotiation breaks down, then if one party is stronger than the other, then he can derive. For example, suppose that if there is no agreement, I am going to get 40 rupees. So then I am in a very strong position. I can say that either you give me more, or I will not agree to anything. You will get 0 and I will still get 40, so I will not. So that is something that can happen. So basically people started with the axiom and then they said, okay, let's test it. Now this is also unusual. Actually only experimental economists do this, and this is what makes experimental economics different from conventional. In the conventional economics they say, here are the axioms, here's the solution, and that's it. Now we know what will happen. We don't need to even look at the world to see if it will happen or not. So that's basically utility maximization theory. We come up with this theory and we don't even need to test it is true or not. It's automatically true. So here, similarly, the Nash bargaining solution is the solution we don't need to test, but the experimental say, okay, let's see if it works, and they find that it doesn't work. So Nydegger and Owen first did this in 1975, even though the theory was available long time earlier. So the baseline treatment was that you put down $10 and you ask people to bargain over it. And in 100% cases, there was just one solution, and that was $5 and $5. 10 out of 10 cases. But does this prove that Nash bargaining solution works? No. The point is that this 50-50 solution will come from hundreds of different ideas about how the bargaining works. So just this is a standard problem, that if my theory predicts X and X is true, then my theory is true. This is wrong, because there may be many other theories which also predict the same outcome. So the real test of Nash bargaining comes in situations where you don't have symmetry, because when you have symmetry, then the theory of fairness, that people will go for the fair allocation, automatically will also lead to the same conclusion. But you don't have symmetry, then you have differences. So there is one of the axioms is independence of irrelevant alternatives. So this can be tested by changing the rules a little, saying that okay, you bargain over this 100, but player A can only get a maximum of 60 rupees and player B can get 100 rupees. So now there is asymmetry. This rules out some of the portions of the bargaining square. So there are some solution concepts which say that in this situation player B has more power because he can get more maximum, so he should end up with more, a REFA solution. But what actually happens in the lab is that nothing changes. So in this situation, the experiment shows that the outcomes are equal. So now this is again what the book says, is that it shows that you have to verify your theories in the lab. And this is actually the case, that what the axiomatic method shows is that you can make any number of axioms and you get any kind of solution, and unless you test it with reality, there is no way to know what will happen. So now the fourth axiom, this also fails. Now this is the interesting place, where what happens is that you make an asymmetric game in which you say, okay, there are 60 plastic chips that you have to divide between yourselves. The chips, if the player A gets them, they are worth 10 rupees. and if the player B gets them, they're worth 20 rupees. So now there are two different focal points. If they divide the chips evenly, 30 to both players, then the player 1 will get 300 rupees and player 2 will get 600 rupees. If they divide 40-20, then both players will get 400 rupees. Now notice that the 30-30 solution gives both the players combined amount of 900. 40-20 only gives 800. And actually, so here, if you want really to get Pareto efficiency, what would you do? Huh? Nahin. Nahin. Pareto efficiency means that you can't give more to both. Well, within this, basically because the chips are worth 20 rupees to B, you should give all of them to him, and then if we will get 60 times 20, 1200 rupees. That's the maximum amount that can be extracted. Now then you have to have a side payment in order to create Pareto efficiency. So now the question is, what will happen? This is actually very interesting. So what I would like to see is negotiations. Okay, so just for the sake of experimentation, why don't you negotiate with him and you negotiate with him? Okay, I want to know which of these two outcomes will happen. So go ahead, you can sit next to each other. This is unstructured bargaining. I want to see what will happen. So you have 60 chips between you and you divide. You come to an agreement. If you fail to agree, then you both get nothing. Discuss with her as to what you will do. Oh, acha, haan, one of the players is advantaged. Okay, so Asma is advantaged here and you are advantaged here. You will get 20 rupees for your chips. Acha, one rule is that there are no side payments. You get what you divide. Afterwards, you can't go and say, okay, I'll give you half of what I earned. So you are player B, you get 20 rupees for each chip. You are player B, you get 20 rupees for each chip. The other player gets 10 rupees. So you have to divide 60 chips. How will you do it? Alright, so there are three possible solutions. There is the equal split, which is 30-30. There is the, equal split is, there is the Nash solution, and then there is the efficient solution, which is 120. Alright, so in the real world, in 10 out of 10 cases, 20-40 split was observed, which is equal money. So this is not the Nash solution. The Nash solution is a compromise between the efficient solution and the equal split. You can calculate it, but I won't. See, the straight line is what player 1 gets versus player 2 gets. If all the chips are given to player 2, you get 60, he gets 60. And all chips are given to player 1, he gets 120. And then the Nash solution is 60-30, which is equal split. Because Nash solution is invariant under linear transformations of the utility. So, so that's now the equal split of money is the 40-20, which gives both players 40, and which is the one that occurred in the lab. So this means that there is a serious problem for Nash solution because it doesn't work. Now, suppose that, so basically it says that linear transformations of utility do not work So basically linear transformation is kind of ordinal utility, although it's not quite completely ordinal, because complete ordinal means that invariance under any monotonic transformation. Now the problem is that if we accept this, then the actual utility function matters. So basically the cardinal utility function matters, not the ordinal. Now the ordinal utility function is observable because you see the choices, but the cardinal utility is not observable in principle. If you assign some numbers, so basically here we have one instance of a huge number of situations where economists are basically blind to the reality. The fact is that cardinal utility works and everybody knows it. And so cardinal utility is observable. It is because it is observable that we can bargain about it. Nash solution is not relevant because it's based on ordinal utility and reality is based on cardinal utility. So what should have happened was that we discard Nash solution and we start working with reality. But this is not what happens. Basically, most of the rest of the chapter is exploring why Nash doesn't work. Now this is sort of a silly question, but anyway, let's go through that because this is what the book studies and this is what you will see in the experimental literature. So even originally the economists said this is the axiom and this is the it. So the experimentals said that okay, let's see if it works, and they found it doesn't work. So then they started to explore, and this is what most of the experimentation is about, is why the theory doesn't work. This is also a misguided application of experiments. Instead of saying why the theory doesn't work, you should look at what is happening and why it is happening on its own ground. After having rejected the theory, theory doesn't work, throw it in the garbage and now start with a new theory which works. So basically this is still not done. This is why we can do experiments in a better way than is currently being done. So basically one idea that came up was that basically the invariance under linear transformation means that the players are risk neutral, and if people are not risk neutral, then this may be the reason why the Nash theory doesn't work. So as I said, this is stupid, but so there was attempt to rescue Nash by invoking failure of risk neutrality. So here is the way the experiment was done. So you bargain over 100 chips now. These chips are each one entry in a lottery. So suppose each chip carries a number from 1 to 100, one of the numbers will be drawn. So each ticket is 1% chance of winning. Now, with this structure, you can prove that there will be risk neutrality. Theoretically. So now you have these tickets. Now there is prize to player A which he gets when he wins the lottery, and prize to player B when he wins the lottery. And these two prizes could be different. That would cause asymmetry. So now what happens in this kind of bargaining? Here the problem of the utility function is bypassed, because in this case, regardless of whether you have cardinal utility, your utility, you can prove mathematically that the actions in this situation will be risk neutral. This is called a compound lottery, where it's a lottery over lotteries, And there is a theorem called Theorem of Simplification of Compound Lottery, where you can combine the two stages and come up with one number. And if the standard expected utility theory works, then it shows that your decisions will be risk neutral in this situation. So, see, if you are choosing between $40 and a prize with 50% and $60 prize with 50%, then your choice may not be the middle, equal to the middle 50% because of risk neutrality. But if you are choosing over 40 tickets for a prize and 60 tickets for a prize, and both of them are equally likely, then this will be equivalent to 50 tickets, regardless of what the utility function is, regardless of whether you're risk averse or risk neutral. So this is basically the way the process works. So now, what do experiments show? So the experiments show something quite interesting, that suppose that the prizes are one player will get $20 if he wins the prize, the other player gets $5 if he wins the prize. So he is the disadvantaged player. So, like we saw in the 2040, what will happen is that the bargain will be struck somewhere in the middle. Here, because the correct, let's see, what is the one at which you have equal outcomes for both? So basically, I think 25-75 will give you equal outcomes, in the sense that 75% of 5, no, that's not correct. I think 80% and 20%. So 80% of 5 will be $4, and 20% of 20 will be 1 over 20. 5 is that 1/5, $4. Yes, exactly. So yeah, 80-20 split would be the one which would give you both $4 on the average. Now, because this is so heavily asymmetric, 4-1, the $20 player could say that, look, if you give up a few, so instead of 20-80, the actual outcome that was observed was 33 and 66. So 1/3, 2/3. $20 can say reasonably to the other player that it is worth a lot more to me to have one extra, so I should be getting more. And so, to some extent, this is a counter factor to the exact equal money division. And so, in fact, the average agreement point was 33%. When both players know both prizes, about 17% cases there could be no agreement. Maybe one of the players insisted that it should be the 80-20, which is the equal split, and the other person wanted to get more benefit, and they could not agree. And there's always a limited time on these, and so if the time runs out and you don't reach a bargain, then you get to disagreement outcome, which is both get 0. Now, when you have the $5 player knows both prices, that $20 player does not know both prices, and this is common knowledge. This is very important, that common knowledge means that both players know what the other player knows. So in situation 3, $5 player knows both prices, and he knows that the other player does not know both prices, he knows only his own price, and the other player, the $20 player, also knows this, that player A knows both prizes and I only know one. So this is the common knowledge. See, when you don't have common knowledge, then you have very serious problems in calculating what is going to happen. So when the weaker player knows both prizes, still you get to the same solution. But if the $20 player knows both prizes only, and the $5 player knows only that he has $5 and he doesn't know what the other player is getting, then you get closer to the 50-50 solution. The $20 player can pretend that he has less, but and he could negotiate harder. He could get to 50-50. Technically, that would be possible. So the 44 suggests that the $20 player is trying to is not taking full advantage of the knowledge, and this is sort of like the ultimatum game where the first player can really freeze out the other player, but usually in the dictator game the player gives something. So here the $20 player is giving something to the other player. But if neither player knows the other, then you get to 50-50. That is the natural agreement point, because you don't know who is getting what. So this is what happens in the real world. Now, the Nash bargaining solution has no place where you can put in this knowledge. Apparently the knowledge doesn't matter, but actually this is one of the most crucial factors which determines the game. So how does the knowledge affect the bargaining? The Nash solution has no information about this. So obviously, if we want to construct a theory of bargaining, we need to have some structure about what people know and also what they think is fair. Because again, what people think is fair is different from what the theory says. So both of these things are not part of economic theory, and that's why you can't get a good bargaining solution. So as the text says, Holt and Davis, that there is no theory which explains these observations. One of the things that we see from the real world is that the level of disagreement is high, about ranging from 14% to 20% in all the experiments, regardless of which way. So this means that the axiom of Pareto efficiency is valid, because when you disagree, then both get zero. So there is no. So it is always to the interest of both parties to agree, regardless of what the bargain is, regardless of what the split is. This is standard like in ultimatum game, that when you reject, then both people get nothing, and so the theory says that you will never reject. But in reality, this doesn't happen. The same thing is true in real world in strikes, where both parties lose from strikes. And there are many situations where both parties will gain from coming to an agreement, any agreement, but still you find that both parties disagree, and this causes damage to both parties. So Pareto efficiency does not hold. Another factor which is seen in the real world is that when you give people time that okay, come to an agreement, usually they're given a fixed amount of time, 10 minutes or half an hour. Then the agreement occurs near the end of the bargaining period, sometimes a few seconds before. So why is this? If there is a situation, and if the Nash bargaining solution is correct, it means that there is some solution which everybody should agree to, because it's natural. So they can say, okay, look, here's the solution, let's adopt it. That would happen in the first 5 minutes. But actually it doesn't happen. So the pressure from the deadline is an important factor. Why it is? There is no theory which explains this. That is because all theories are based on axiomatics, and none of the theories are based on trying to understand real world bargaining behavior. So this is called the deadline effect. So one of the things that comes out of the experiment is that the information matters. Who knows what? So this theory, bargaining theory, is often used in trying to understand labor strikes. So in labor situation, what happens is that the laborers want to have higher wages. So they negotiate that, okay, next year our salaries will be 10% higher or 20% higher. So obviously one very crucial factor here is how much money does the firm have that it can give. So now the firm has excess profits, it has money which is known to it, but the laborers usually do not have some knowledge of this. They have some guess about it, which is called a stochastic distribution. So now things the experiments show that whether or not strike occurs depends a lot on this kind of structure about information. So for example, suppose that the laborers know that there is a good chance that P is very large. They don't really know P, but suppose they say that they think that there is a 75% probability that the profit that the firm has is very large and 25% that it is normal. In that case, laborers will make a high demand. Now the firm might refuse, but the refusal could be for two reasons. One is that the profits are not really large. The firm laborers have wrong information, but it could also be a negotiation strategy that they want to keep more of the money. They will claim that no profits, you are wrong, we didn't make so many profits. So nobody knows, and it's very hard to find out. So in that case, the strikes are likely to happen and more disagreement will occur in this kind of a situation. But suppose that P becomes common knowledge, everybody knows, then in this situation strikes become very uncommon and people come to an agreement. So if the amount is known that this is what the firm has, so people will come to an agreement that okay, let's divide it 50-50, you can have half, and the other person will also agree. But if the P is unknown and there is asymmetric information, then you will have disagreement. Because, so what this means is, what this reveals is that people have a common understanding of what is fair. So when you have lack of knowledge, that common understanding still exists, but you don't know, you can't come to agreement because people are revealing their information. So the shopkeepers keep saying that, this is, ye to mere khareedi nahi hai, this is not my cost, because everybody understands that it is not fair to buy something from somebody at a price which is lower than his cost. So, but the question is not whether the question is whether you trust this statement. And often the shopkeeper will pull out his book. He will say that, look, this is the invoice from and you still don't trust it because the invoices can be faked. So this is the thing, that the knowledge is what matters. It's not. So now this is something which economists do not understand. Economists don't have a concept of fairness. So if there is a knowledge of what is fair, then complete revelation is a way to get to agreement. Now the Islamic Murabaha contract is based on this exact concept, that Murabaha happens when I buy something and I sell it to you. I act as your agent, but I take a profit. But everything is known to everybody. That okay, I will buy this for 100 rupees, I will sell it to you for 120 rupees. Okay, I agree, you agree that, okay, I have done some work, I deserve some profit, and the prices are known. See, if the price is unknown, then there is an issue. How much profit is this middleman making? So this is taken out in the Murabaha contract. Everybody is supposed to know everything, and then there is no difficulty. All right. So the next issue which is handled, which people try to handle, is that they say, okay, the problem that we have loss of Pareto efficiency, this happens when, you see, one player is getting 20 rupees, the other is getting 10 rupees. So Pareto efficiency demands that the first player should get everything, but of course that's highly unfair. So now how do we create Pareto efficiency in this situation? So that is basically the Coase theorem. It says that give property rights to one person and force side payments. So if you have side payments, then this problem can be solved. One person gets, the person who can get more takes everything, and then he pays the other player. So he says that now the Coase theorem is based on a very interesting insight that, okay, suppose we are bargaining over these chips. Suppose that all the chips belong to either party, whether the stronger party or the weaker party. It doesn't matter. As long as you allow side payments and you have property rights, you will get to efficiency. Why? Well, suppose that the weaker player owns all the chips. So he is only getting 10 rupees. Then he says, okay, I will sell these to you because I will only get 60 if I keep them, and you will get 120 if you get them. So, but I will sell these to you for a fair price. So now, since he owns property, the other guy has nothing if he doesn't buy. So for him, the value is 1200, and so he will give some fair share. Actually, the disagreement outcome is 600 rupees for one person and 0 for the other. And in the case of agreement, he gets 1200 and they have to share. So one fair solution would be that, okay, he gets 1200, he splits it half, 600, but that would give nothing to the other player. So probably another fair treatment would be that he gives 300 to the other person. So that means that he gives a 900 rupees and he retains 300 rupees. So that's one focal point, but probably this will not happen. It will be somewhere between these two. And now this is something you can test in an experiment. So here is a game which is designed to test this kind of situation. Here the underlying model is that there is an activity which causes externalities. Player A is running this factory which creates pollution or causes some damage to the B farm, which is the player B. So if the player A does nothing, then the profit for player B is 12. If player A does activity at the smallest possible level, he gains 4, but there's a damage of 2 to player B, so his profit goes from 12 to 10. Activity level 2, the profit increases. For each activity level, you have increasing profits for A and decreasing profits for B, because you have more externality. And so there are two points which are worthy of note. First of all, there is the zero activity level, which is the best for B. One activity level is joint maximum, 14. Two activity level equalizes the outcomes for both. So this has a certain fairness property. At activity level 3, there is a lot of damage to B and more profits to player A. And generally, if you want to maximize A without regard to B, then it's activity level 6, which gives 0 to B. So what will happen in this game? This is actually, again, something which is an experimental situation. So suppose that you were bargaining in this game. All right, let's have a little simulation. Yes. Let's see. Who was the advantage player in the first game? Okay, so both of them, Bs, were there. So let's see now.
Activity also.
All right, so player B in the last game is player B in this game, and player A. So you're B, you're B, you're A, and you're A. So you decide on player A has to choose an activity level, and as long as player B agrees, and this time currently we have no side payments. So if you agree, you get what is written, and if you don't agree, both sides get 0. So let's see what happens when you negotiate.
Two, sir. Activity 2.
Both sides choose 2. This is the correct. All right, so this is a picture of the solutions. Oh, I forgot about a detail of this game. You can have, and this is the way they did it, one of the players was called the controller. That's exactly the Coase Theorem. That okay, so you give property rights to one of the two players. So he gets to call the shots. Whatever he decides, the controller decides the activity levels, but the other player can negotiate, and there can be a side payment. This is the game which translates this into a Coase theorem. That okay, either one of the players, the controller is the one who owns the property, and so if B owns the property, he can forbid A from doing anything, and so he can force the 0 outcome, but A can offer him a bribe that okay, if you allow me to do the activity, I will pay you so much. Alternately, A can be the controller, and then he can say that okay, my maximizing profit is 6, and that's what I will do, but if you pay me something, I might do less activity. So these are the two Coasean solutions. So here is the situation with all possibilities. So if B is the controller, then the Nash solution first of all, it has efficiency, so it will always be 1, activity level 1. Now, at activity level 1, if B is the controller, he will say, okay, I can make 12 on my own with this agreement. So I need to make more in order for me to allow you to do 1. So at 1, basically the amount, so the A, for A, the default option is 0. So if he is allowed to do 1, he will earn 4. And from this 4, he must give 3 to B, which is basically in fact giving him only 1 surplus. So B gets 1 surplus and he gets 1 surplus, and this is equal surplus. So this is the equal division of surplus. So that is the Nash solution. 13 for player B and 1 for player A. Activity 1 is 10 and 2 and 4. Equal split is 7 and 7. Why is it 7 and 7? Oh, I see. Equal split is 7 and 7 efficient on the efficient frontier. So what you should do is that you should both produce 10 and 4 and then just divide it equally between the two of you. 6 and 6 is the equal split according to the game without side payments. With side payments, it is the straight line, because with side payments, what will happen is that you will always produce 10 and 4, which is the maximum, and then you divide it any way you like. But without side payments, you have inefficient outcomes, because as we have seen. So 6 and 6 is an inefficient outcome, because both can get 7 and 7. It's not Pareto efficient. If they say that, okay, instead of equal payments, we go to the maximum and then we divide. So what will happen in the Coasean version? Shall we try it? Okay, let's go to the... Now, let's say that A is the controller now, and now you negotiate. So A can do whatever he likes, but B can offer to pay to something to prevent that from So what is now the solution? Yes, go ahead and bargain.
So property belongs to A?
Property belongs to A. A gets to choose whatever activity he decides, but you can ask him to take your feelings into consideration. And from the amount that you get, if A reduces, if A plays 6, you get nothing. So any amount that you earn is at the mercy of A. So now A you can say that, okay, if you produce at certain level, I will get this, and from this I will compensate you this amount. From your 4 payoff, you can pay her 2 or something, whatever you like. But that won't be enough, because if from your 4 payoff you pay 2, she gets 11 by doing 6.
One, sir.
Yeah?
One.
So activity level 1, and what's the payoff? What's the side? Side payoff क्या है? What is the final outcome for both? बराबर बराबर नहीं बांट रहे हो? क्या हो गया? एग्रीमेंट हो गया? एग्रीमेंट नहीं हो रहा, डिसएग्रीमेंट आउटकम हो जाएगा. Right, I think I have to use the deadline effect. You have 1 more minute to come to an agreement, okay? So in my watch, okay, you heard that? Deadline effect. 1 minute to come to an agreement, otherwise both people get nothing.
चलो 11 सर
11-3. You will you will play activity level 1 and you will take 11-3. This proves that both of you are economists and think like economists, because this is not what happens in the real world. This is what the economic brainwashing does. हाँ, exactly. हम लोग ने Nash equilibrium calculate वगैरह कर रखा था, तो everybody was doing this. But in reality, what happens, we will see. Here is the data for a single Pareto. These people have not been trained in economics and have not calculated Nash equilibrium. So, in the case of complete information, there were 12 pairs. Now, in 11 out of 12 cases, they agreed to the joint maximum, which is 12 and 2, right? 12 and 10 and 4, say. So 11 out of case. Now in 5 out of these 11, there was equal split or within $1. So 7-7. Now this is a serious problem for economic theory because it conflicts with rationality. The people just agreed that okay, let's pool and let's split, even though if the controller says that we do not come to an agreement, this is the standard, then I will get 10 on my own. So why should I give you 3? And suppose they say, so the disagreement outcome is that the controller as B, he gets 10 and the other party gets 0. So now the bargaining outcome, which happened in 5 out of 11 cases, 5 out of 12 cases, was that they said, okay, let's pool, we will get 14 and let's divide equally, 7-7. So this is not individually rational because the controller on his own can get 10. So what this shows is that people care about other people's outcomes and people care about fairness. Economists do not, because economists have been trained otherwise. Now in 7 cases there was individual rationality, so that the controller said that I get 10, so at least I must get 10. So possibly the division was 10 and 4, that okay, as long as I get what I'm making, I will allow you to make some more. So this is a reasonable solution. It is not the Coasean solution, but it is a human solution. Now when you have partial information, so neither side knows what the other happens, then you still get very similar results. Now the individually rational behavior goes down, equal split goes up. Why is that? Now to understand this you have to know about human behavior, not about economists. If suppose that everyone knows only his portion of the table, his line, he doesn't know what the other line is, but he knows that generally that is going up, and that our incentives are misaligned. So why will it happen that you get more equality and less individual rationality if people don't know each other's outcome? It is actually obvious. You see, in the negotiation, if I can say that, look, I'm going to get 10, so you must at least give me 10. As long as this is credible, as long as the invoice that the seller shows, okay, this is my khareed, this is my purchase cost, is credible, then there is no problem. People will agree to that this is the minimum that I should pay. So that if there is knowledge of this, then people will agree that, okay, you shouldn't go below cost. But if there is no knowledge, he can claim that, yes, this is what I am getting, but you don't know, then he will not be able to insist on this as a bargaining point. And the other party might bargain more strongly. And now, as long as, so now the concept, and now the other party could say, look, in the case of the controller, he can say that, okay, I don't care what you're going to do, and I will just stick by my. But fairness plays a role, and as long as the party, instead of doing something which is unfair and inefficient, he agrees that, okay, let him have a little bit more because it seems fair. So fairness matters more than individual rationality. This is very important, that people are normally value social consensus more than they value their individual self-interest. And this is how people are trained in societies. Children receive training that, look, you shouldn't be selfish. If there is something, even if something hurts you, if it is good for the group, you should do it. And this is what the behavior is showing here. But economists are trained to believe otherwise. Now, one more treatment was the paid treatment, where the people said that, okay, whatever happens, we are going to play another game in which the roles will be reversed. In this situation, there was 100% even splits. Everybody agreed to 7-7. Now, the economists don't like this because individual rationality is violated in both of these games. So they said that this is because you are playing for peanuts, $10, $12. So these experiments were replicated with high stakes and came to the same results. So basically what this shows is that the Coase theorem doesn't work because social cooperation is more common than economic theory says. So people voluntarily forego their property rights in the interest of fairness and equity. And actually this is a very important difference between Islamic concept of property and Western capitalist concept. In the capitalist concept, once you have property, then you have absolute right. But in the Islamic concept, nobody has absolute rights to property. It's only Allah Ta'ala has absolute rights. We are given property as a trust and as a test that if I have property which is in excess of what I need, then it is not mine. It is a test to see if I will use it for the benefit of the others. So this is not mine to do with what I please. So even if you have the property right, it is still just a test for you that can you use this. So in that case, you will say, yes, okay, I have been given this by the experiment. Doesn't mean that it's mine to do with as I please. It means that I should deal with it fairly, which means giving equal to both parties. So now the next set of experiments by economists, because you see this is again, economists say that no, people must be rational. So if this experiment is failing, there is something wrong here. So how can we ensure that people are individually rational so as to make sure that our theory works? Now the thing to do is to abandon the theory. This is not correct theory. there is another question that will people go for the joint maximum even if there are no side payments? So we have already seen the answer to this second question. So the same experiment was replicated, but there was no controller, and it was just like ultimatum game, which we actually, I think we did that earlier. So we came to the 6-6 in the ultimatum version. And this is actually what happened. Equality dominates, so people chose 2. So the joint maximum is not the one that is chosen. So Pareto efficiency is abandoned in favor of equality. So now suppose that we increase the difference. What happens? So the game is changed here. All other payoffs are the same, but at the joint maximum, you have 5 and 11 instead of 4 and 10. So what do you think will happen in this game? This is like the ultimatum bargaining. Joint decision, if you agree, then you get what you agree to, otherwise both get 0. So what will be the outcome here? In the previous game where you had 4 and 10, the outcome was 2, 6, 6, equality. Will we still get equality in this game? No, there's no side payments now. See, the experiments among economists are biased because the economists have wrong mindsets. One pay, exactly. This is what happened in reality. Why? Because of social thinking. 2 said that, okay, let me give up 1 because you will get 5 in result for that. So this is too heavy. And the other person said, look, why don't you? Why are you being so selfish? Equality is not so important. If you just give up 1 of your profits, I can get 5. So as long as we care for each other, which is what is not assumed in economics, then this is perfectly reasonable. Everybody will agree that okay, I can suffer loss of 1 if you get the benefit of 5, which is as if tumne khaya to maine khaya.
Social cooperation.
Social cooperation, exactly. So joint maximum now dominates. So the results show that people are not fully social, that okay, tumne khaya to maine khaya. If tumne khaya to maine khaya is the dominant philosophy, then you will always get to joint maximum. But to some extent, I mean, there is individual rationality, selfishness also exists, but social thinking also exists, and some compromise between these two is what really happens in real games. Now what I am trying to say is that economists have no idea about human behavior. The experimentalists are also handicapped because instead of studying real behavior, they are trying to fit economic theory onto behavior, and so they are having real difficulty. They are conducting the wrong types of experiments. So we have the opportunity to create a good theory of human behavior based on introspection. If we think about how human beings really behave by looking at ourselves and also by asking people why they do what they do, then we can get to a much better theory. So now this experiment is one of those bad experiments. Instead of trying to find out what people behave, they are trying to rescue the theory. So okay, so the economists say the way economists think, which I am just illustrating how economists think, not how they should, what we need to think. Economist says that, okay, the reason that the controller is not making an individually rational choice is because he has been awarded this at random. So he doesn't really own the property. I mean, we have given him ownership, but it's artificial ownership. It is not his genuine ownership. So suppose we make this, make him earn this controllership. Then he will say that this is really mine, and now he will act in an individually rational manner. So there are two ways in which the ownership was made his by in the experiment. One was that in one case we chose the controller by coin flip, so it's clearly arbitrary, and the other one was that there was some game of skill which the two players had to play, and the one who won got the right to be controller. So now you have won your controllership, so you own that controllership. Also, in the experiment instructions, one of the instructions says that player A is designated to be the controller, or player B is designated to be the controller. So it means that I am choosing the controller. He didn't earn it. Or the other experiment, player A earns the right to be the controller, or player B earns the right to be the controller. So again, the terminology indicates ownership instead of arbitrary choice. So here's the 4x4 table. So it shows that in the case where is designated is used and coin flip is used, so this is the least ownership, the gain to the controller is 1. This gain is over the equal splits, which was 7-7. So basically on the average, the controller earns 1 unit in the baseline treatment where choice is random and is designated is used. Now, when you use is designated and you use selected by game of skill, it makes only a minor difference. Earnings go from 1.0 to 1.2. So the ownership does not come about so much by the winning at the game of skill. What we are exploring here is something which is not understood by the experimenters. What we are doing here is trying to understand what is it that people think is fair. So do people think that if I win against you in a game of skill, and by that victory I acquire this property, does this belong to me? If this is a social consensus, then people will say, okay, I can earn 10 on my own, and this is mine by right. So if I give you the right to pollute and reduce my earnings, you should compensate me. So I should get at least 10. This is the property right question. Now, if it says that no, you are making 10 only because the experimenter has set up this situation, it's not yours. Let's just try to make the most we can together and let's split it equally. That's a different situation. So what we are doing is, it is not understood here. What we are doing is we are exploring the social norms which govern the situation. To what thing will people agree as being fair? This is really the central question. So it seems from this experimental result that just by winning a game of skill, like chess or something, it doesn't give you the right to own that property according to social consensus. Not if in a different society this is considered as social consensus, then it would give you the right, and then you would reason in this way. But for the particular case, it did not. But the terminology was very important. When you switch to, even with the coin flip, if you switch to earns the right, then suddenly this phrasing by the experimenter leads to a gain of 2.6, which is more than the game of skill. So if you look at the social norm, this is what we are really exploring. The social norm of getting the right to property by winning a game of skill. There's a famous story that Dilaram and the king, he played a game of chess in which he the prize would be Dilaram. So this way of transferring ownership by game of skill is not generally accepted as a valid way of winning the right to property in this particular experiment, but it can change according to social norms. But if you use the earns the right, that gives you the right, that is more valid as a property right. And then if both of these treatments are present, so now when you have earned the right and you have the game of skill, then that gives you the maximum return. So this terminology together with game of skill is gives you the maximum return of 4.5 over the equal treatment. So basically what Ariel Rubinstein, who's a very famous game theorist, he says that economists are victims of game theory because they have learned game theory, so they have learned to understand the world in a way different from what most normal people do. So they make the wrong predictions, they make the wrong actions because they have the wrong theory. They have these blindfolds over their eyes created by game theory. So he gives this example of the ultimatum game which is described. Now he says, I have data on about 12,300 people about how you will divide in ultimatum game, and nearly half of the people do a 50-50 split. And that's the natural thing to do. And those people who don't do 50-50, they do close. It's like 70-30 is between 50 to 70 is 90% of the offers. Now, what about there are some people who say that, okay, I will take $99 and I will give you $1. So who are these people? These are the people who are the victims of game theory. They do not understand real human behavior because they have been conditioned to think otherwise. They say, okay, $1 is better than 0, you will take it. This means that they have really lost their minds in the sense that this is not, they have been trained to think that people are selfish. I remember that the first time I taught this, there was an economist and he was very strongly arguing with me that no, this cannot happen. How can person take 0 when he can get $1? And so he was one of those victims of game theory. Now, these people who know game theory, if they play this game, they will get much worse results than real people because they will offer $1 and they will be rejected, they will get nothing. They will think I am going to get $99 and they will get 0 because they don't understand human behavior. And so he says that if they played the game, achievements would be, and in real life also, they will do worse than other human beings because they don't understand human behavior. So the same thing is true of economic theory. The people who study and understand and learn economic theory will do worse in real life and will do worse at understanding real human behavior. There's another quote by Rubinstein. He said that nearly every book on game theory says that game theory is application to this, that, X, Y, Z. But after nearly 40 years of studying, I have yet to find even a single application of game theory in my daily life. It just doesn't work. Now, the ultimatum game, we've already studied this. This is the reality. Ultimatum game is the dark black panel, the triangle. Basically, it shows that in the ultimatum game, people mostly come to 50-50 splits. Now, when you have the dictator game, there is a small percentage
which is doing 50-50 splits, but there is a much larger set of people who are doing 30-70. They are taking advantage of their dictatorship, but they are not giving zero. The economist solution, which is that you take everything and you give nothing to the other, is chosen by a very small number of people. These are the victims of game theory, the ones who say that, okay, social norms don't matter, I should be completely selfish because that is a rational thing to do. Now, why does this happen? Again, economists are very, very perplexed by this. They say, okay, it is the experimental, it is the dictators are acting in this way not because they fear rejection, but because they fear that the experimental will think badly about them. So this also works. The double anonymous game is the one in which nobody knows who did what, and especially the experimenter doesn't find out what the dictator did. There is a way to arrange this experiment so that this can happen. So in that case, you get a lot of dictators who are giving zero to the other party, but a lot of people still give something to the other. So what this shows is that people respond to social norms, that they are concerned about what other people think, and if other people think that this is fair, then they will act fairly, even if they are very evil people. And this is actually something that is true from Islamic history. People who were bandits and robbers and very evil people, they would take lots of money and they would donate it to good causes. They would build masjid, they would build madrasa and so on. So and this is, we know, because social norms are important. So if there is social norm of charity and generosity, even those people who are not charitable, who are very selfish, they will behave generously. Now this is something which economists don't understand. That's why it's very important to promote social norms of generosity, to praise people who are generous, even and to say that people are generous. And when we start saying that no, everybody is selfish, this promotes selfish behavior, because people say, okay, I can be selfish, no one will think that this is bad. So one of the key findings that we learned from game theory is that people act in two different ways. People have two different characters, like there's a Dr. Jekyll and Mr. Hyde. So there is a social frame in which people act according to social norms, and there is a market frame. Now if you are buying and selling, suddenly you put on a different hat. Now you are not concerned about what people think, you are concerned about maximizing. These two are opposed to each other. These two frames are opposed to each other, they are in contradiction. And we can get any result we like in an experiment by switching the framing. So the contradiction is revealed. Ariely gives this example, that suppose that your mother-in-law cooks a tremendous dinner for you, and you have, oh, mother-in-law, this is so delicious, I will pay you $100 for this. So your wife will be very angry. What is this? So that just shows that the contradiction between the market and the society. So now in an experiment, you say, we asked people, this is a real experiment, that okay, here is a library and we want to catalog the books, and everybody who passes by should do this because it helps everybody. So people worked, and you can say, okay, I will pay you some money. Then again, now you have an entirely different situation. A very famous experiment was blood donations. So if we want you to volunteer to give a blood donation because it will help save lives. Lots of people volunteer. Say, okay, I will pay you 100 rupees for 1 pint of blood, or 1,000 rupees. Very few people will donate. You won't get. In fact, the class of people changes. Now the students, even if you give 1,000 rupees, 2,000 rupees, you don't want to sell your blood. But if somebody is very poor, they will do it. So the market transaction is extremely different from the social transaction, because people, economists especially, don't understand this. So they keep trying to understand what human behavior is. They keep failing because human behavior is not the same. It changes according to the frame. So this is called the framing effect. And they don't understand, because according to the rational choice, there is only one rational choice, but it doesn't work. So, alright, I think, alright, let me just briefly mention this issue, which is covered in the last part of this. So this finishes the bargaining part. So you have multi-round games in which basically like prisoner's dilemma, repeated, etc. So according to the backward induction story, you start at the last, you optimize, and then you work backwards, and you can calculate the optimal strategy. And when you do that in the prisoner's dilemma repeated, you see that in the last round everyone must betray, and then you carry it back, and it turns out that in every round you must betray. And there are many other games like this where you can calculate the optimal strategy by working, starting at the end and then working back. Now when you try this in real games, people don't work like that. Basically this is an illustration of bounded rationality. Even when people are acting in, are put in the market frame, so they are acting selfishly and maximizing, even then they cannot calculate the optimal strategy easily. So what you have is something which is called, people don't use backwards, they just solve the problem currently, and then they say, okay, next problem we will solve when we get to it. So now when you do it repeatedly, then in the last round they learn what they should do, and then when you do it the second time, they know what to do in the last round, but and they can then in the next to last round they understand what is going to happen, and so they fix that. So basically if you put people in this situation repeatedly, then eventually they learn to use backward regression one step at a time. They learn in the period n, then in n-1, n-2, eventually they learn backwards. So learning does happen, and people can learn how to do backward induction, but only this is what's called swing back. People learn in the last round, and the line swings back period by period backwards. Okay, the main results of the ultimatum game. There are 2 lectures on this, so I would like to ask you to watch one of those lectures, which I have done in previous courses, because those lectures were solely concerned with the main results of the ultimatum game, and so those are discussed in great detail. This particular textbook doesn't, just briefly describes the ultimatum game, so I will just assign you to that. And I'm planning to do an experiment next time. I would need about